All right, let's do it. Emma, thank you. All right, anybody watches this video, you owe Emma all the credit because she remembered. All right, here we go. So when we're working with functions, right, we're going to actually work with them now, which is just a lot of plugging numbers in and see what comes out. But let me just give you a really quick rundown as to what we found out a function is, all of its fancy definitions. A function is a relation where each input has exactly one output, right? If 2 goes in and makes 7 come out, then 2 can only make that 7 come out. He can't make all of a sudden a 9 come out. That would not be a function. All right, it's an input-output machine. You plug something in, the function does something to it, and it comes out. The way we work with functions is we plug x into the function. The function will have some type of mathematical rule programmed into it, like maybe x plus 5, right? It'll take that x value, add 5 to it, and then it'll spit out the y value, the output. That's how we work with functions. And you can start building that set of ordered pairs, that relation, by taking your x, your input, and your y, your output. And there's your ordered pair. All right? If you're looking at a list of ordered pairs, we can tell right away if that list represents a function as long as the x's do not repeat, right? We don't want to see that one x can make 2 different numbers come out. All right? Some people would say that a function is a dependent relationship between 2 variables. It is dependent. Guys, your y, your output, always depends on your x. What did you plug in? The output always depends on the input. So it's a dependent relationship. It's usually going to be given to us from now on as some type of equation or written mathematical rule, like x plus 5. They're going to give it to you as some rule. All right? And then they're going to use function notation. This is f of x. That's how you read function notation. Function notation is literally telling you a story. You're going to go to function f, you're going to plug an x value in, and then something's going to happen to that x value. That's why I prefer functions over equations. Functions, I feel like, tell the whole story, where an equation just kind of leaves you hanging at the end. All right, so first we're going to work with an equation, and then we're going to work with this equation in function form and see how it's really the exact same thing. All right, so guys, let's pretend I gave you the equation, y equals 2x plus 5. If I asked you to find y if x equals 3, does anybody know how you have to do that? How do you find y when they tell you x is 3? What do you got to do with 3? Plug it in. That's exactly what you have to do, because that's what a function does or an equation. You plug stuff in, right? So if we want to find y and x is 3, we're going to plug 3 in for x. So y will equal 2 times, not x, but we're plugging 3 in, and then plus 5. And then it's all about your PEMDAS skills, the order of operations. Do you want to multiply or add? Multiply. 2 times 3 is 6, plus 5, 6 plus 5, y equals 11. So the answer to this is y equals 11. But this is what I don't like about an equation. I feel like we're left hanging. It's like, okay, y equals 11. But why did y equal 11? Y equaled 11 because x was 3, where a function is going to tell that whole story, okay? All right, for time-saving purposes, guys, I'm going to skip this one because I don't think we need to do it. Let's just go to the next example. Let me show you what it looks like in function form now. Oh, it's okay. Okay. Oh. Is this the first time we're hearing the beep in person?
I missed that sound.
Did you hear it? I beep, guys. You'll learn that when you hear that beep, it's today I have to change my insulin pump, and it's going to beep at me until I do that. So, there you go. All right, here we go. So now we're given the function f of x. So guys, this is the function f. F is the name of it. X is who's going in, and then this is the mathematical rule. This is what's going to happen to x once you plug it in. You're going to times it by 2 and add 5. So that's what would live inside the function machine. That's the rule that would live inside of there. So now they haven't written it as y equals, they've written it as f of x. Now it's in function form. So the way they ask you to plug 3 in is they ask you to find f of 3. Whatever they write inside of those parentheses, that's what you plug in for x. So we're literally going to plug 3 in for x. Whatever is written in those parentheses is what goes in for x. They are telling us to go to function f and plug a 3 in. So let's do it. F of 3 is going to equal, we're going to it, we're plugging 3 in for his x. 2 times 3 plus 5. Now guys, look at this. This is what I feel like students get confused with the function, and it's not everybody. Some people have no problem with functions. But every year, there are a handful that really mess functions up. And I feel like they write this and they're like, all right, now I'm solving for f. I legit have seen students try to solve this for f. Just remember, he's just telling a story. This is function f. We went to him. We plugged a 3 in. This is what gets you your answer. All you got to do is plug that into your calculator, and that's the answer. All right, so if we do that, we already know 2 times 3 is 6. 6 plus 5 is 11. So f of 3 equals 11 is your answer. And this is why I like function notation. It tells a story. How did I get 11? Let me tell you. I went to function f, I plugged 3 in, and I got 11 out. The function tells the entire story, okay? Now, because it's a function, which is a special kind of relation, and a relation is a set of ordered pairs, our books sometimes will have you start building that set of ordered pairs. They'll have you write your answer as an ordered pair. So 3 went in as x, and 11 came out as y. So you can also write your answer to a function as an ordered pair, because the ordered pair tells a story. 3 went in, and 11 came out. I'm pretty sure, though, Delta Math just makes you put 11. They have like f of 3 equals, and then your answer box, and all you have to type in is 11. But our math book either made you write this, and then sometimes the directions would say to write your answer as an ordered pair. So I want you guys to be aware of it. All right, everybody right now, find the f of negative 4. If you want to find f of negative 4, just do what it says. Go to function f, plug negative 4 in. Right? I went to function f, I plugged a negative 4 in for x, so now it looks like this. This is what gets you your answer. Type that into your calculator, hit enter, does the entire thing for you. Anybody brave enough to say what they got? You can just say it if you got it. Negative 3. F of negative 4 is equal to negative 3. I went to function f. I plugged in a negative 4, and I got a negative 3 to come out. So you could also write that as, in ordered pair, negative 4, negative 3. Okay? All right, perfect. All right, so that's the only difference. That's the way it's written, but it's still just plugging stuff in, whether you're using an equation or whether you're using a function. So an equation, it looked like this. Y equal 2x plus 5. A function looks like this. F of x equal 2x plus 5. So if you're one of those students, you're like, God, I hate this function crap. It just always throws me off. Just know that if y equals this and f of x equals that, well then guess what y and f of x honor each other? They're the same thing, guys. In math, you're allowed to interchange a y with an f of x. Or you're allowed to interchange an f of x with a y. So in the future, if you get a function, you're like, nope, not doing it. If you want to put a y there and turn it back into an equation, go ahead. It's the exact same thing. If that makes it easier for you guys to think of, okay? All right, so if you ask me, when you're working with functions, they're only as difficult as the written rule itself. What do you have to do to x? Is it easy or is it difficult? That's the only way they can make functions hard is by making the written rule more difficult. All right, let's practice a lot. Catch my breath for a second. All right, here we go. We are given a new function. I probably should have switched up the letters because a lot of times they'll use G, they'll use H, they'll use all kinds of letters. It doesn't have to be F. Because remember, F is just a name. Given the function f of x equals negative 2x squared plus 3x minus 1, right? So f is the name. We're plugging x's in. This is what happens to that input, to that x value. That's what would live inside of the machine, right? In part A, they want you to find f of negative 3. So they want us to go to f, and who do they want us to plug in, guys? Negative 3. Let's do it. So f of negative 3 will equal, we're plugging -3 in for all of the x's. So it'll be -2 times -3 squared plus 3 times -3 and then -1. And again, this is just telling the story. In order to get the answer, plug this into your calculator. I need another card. What do we have? Do you have blue? Don't you have blues?
Yeah.
I borrow blue. Here's what I want. All right. This is what's going to get you the answer. So you can either PEMDAS it yourself, order of operations, or just plug it into your calculator. That's going to get me 9, -18, -9, -1 comes down. Anybody want to share what they got? If they're willing to tell me what they got as their answer?
-28.
-28, right? So -3 goes in, -18, right? I got 9. 9 times -2 is -18. That's a -9, and then bring down the -1. Order of operations. All right, so you get -28. So f of -3 is equal to -28. I went to function f. I plugged in a -3, and a -28 came out. Beautiful. So now you could write it as an ordered pair. Guys, what I don't want you to do, don't ever write this. Please don't tell me f of x equaled -28. No, it didn't. F of x is actually equal to this rule. That's what f of x represents. It only equaled -28 because a -3 went in. So please don't write that as your answer. All right, you guys do the next one. Find the f of -5. Go to function f, plug in a -5. All right, so if you're a calculator person, because I know I like my calculator, that is what you would plug into your calculator, because this is just telling the story. I went to F, I plugged in -5, this is what happened to -5.
Wait, Miss Carter, I have test quiz. Does it matter which one you write?
Nope,
Or-
unless I put it in the directions.
Okay.
Now, I'm pretty lenient. Sometimes students just write -28, and I'm like, okay, it's right. I really want this or this, because they tell the full story. And then sometimes on quizzes it'll say, write your answer as an ordered pair, and students still write that. All right, so who knows what'll happen this year. Well, I'll make sure I'll tell you which one I want. All right, if we're PEMDASing it, anybody want to say that? You can just say it out loud. I don't have to have any hands raised. Anybody get an answer?
-66.
Yeah, I don't know who that was. That you, Jack? Yeah, or Mackenzie? I don't know. Let's go, Jack. So we got f of -5 equals -66. Beautiful. -5 went in, -66 came out. All right, everybody do the last one. Get me f of 4. I'm gonna...
I'll have to say the answer.
Give me 1 second, but yes, you will be. Absolutely. Hold that thought. All right, we're going to F. We're plugging in a 4, and this is what happened to that 4. And then you're going to PEMDAS it or let that beautiful calculator do its job. Give it to me, Mackenzie. What'd you get?
-21.
I got, anybody here get -21? Yes, we're good. -21. If you go to function F and plug in a 4, you will get a -21 to come out. All right, so 4 went in, -21 came out. So guys, right now, I feel like with the type of functions we'll be seeing, that's probably as hard as the rule will get right now. They keep it pretty simple, nothing crazy right now. All right, we're going to example 3. They've given us a new function. Now we have the function f of x equals this. When I go to f and plug x's in, this is what will happen to that x value. Let's find f of -12, right? F of -12. We're going to f. We're plugging a -12 in. Let's do it. For you calculator lovers, you could do this.
Can I see the answer?
Yes, for just 1 second, Jack. Nick, how you doing? All right?
Good.
Hang in. Okay. Or you could just say to yourself, what's a negative times a negative? A positive. Half of 12 is? 6 plus 6. Jackie, what'd you get?
I got 12.
Thank you, Nick. Good job, Jack. We get 2. We got 12. All right, we get 6 plus 6 is 12. Nick, I know I never care about that, so please say the answer if you know. F of negative 12 equals 12, right? We went to function F, we plugged in a negative 12, we got a positive 12 to come out. So negative 12 went in, and positive 12 came out. All right, last one over here, find the F of 7. And we're going to skip down. You will get a fraction or a decimal for this one, depending on how you leave your answer. Everybody at home, are we feeling pretty good? We good? Yeah? Okay. Anybody want to tell me what they got, whether it's a decimal or a fraction? 2.5, right? We're getting 2.5 as our answer, right? 7 went in, and a 2.5 came out. Or, if you have the fraction, it's 5 halves. 7 went in, and a 5 halves came out. Everybody at home okay with that? Yep. All right, so then again, you could say 7 went in, 2.5 came out as an ordered pair, or 7 went in and 5 halves came out. Awesome. All right, guys, for time purposes, I'm going to skip C and D right now because they're not on your homework tonight. So I want to skip down to example 4 because that is on your homework, all right? And then we're going to stop after these 2 examples. All right, I'm trying to throw a little bit of a curveball at you right now, so just be careful. All right. Okay, so guys, if a function is an input, I'm deep in here. If a function is an input-output machine, then there's 2 things that can happen. Either they can give you an input, you plug it in and find the output, just like we've been doing, or they can reverse it on you. They can give you the output, and now your job is to find out who did they plug in. So just you have to know the difference between those 2 questions. So if you look, all right, you've been given a function. This is function f. When you plug an x in, this is the written rule. This is what will happen to that x value. All right, look at this one. It says if f of x. So guys, if you notice, they didn't give you an input because this is where the input always is, right? If we want to find f of negative 3, we put it in the parentheses. F of 0, we put 0 in the parentheses. These are all inputs. They didn't give you an input. They're saying if f of x equals negative 28, they're telling you who comes out. Your job is to find x. Your job is to find out who went in to make this your output. Now again, sometimes you can just do this in your head because the functions aren't that difficult. However, to set it up algebraically, you need this function, which was 2x minus 4, to spit out a negative 28. So take the function, 2x minus 4, and set it equal to the output. And now you can solve this teeny tiny equation to figure out who must have went in. So it is crucial that you know the difference. I cannot tell you the amount of times on a homework or a quiz or a test, we give the students this problem and the amount of students that just plug negative 28 in. Negative 28 is not an input. Please don't plug it in. He is an output. We have to find the input. So to solve, we'll just add 4. Hopefully the solving is super easy. Divide both sides by 2, and who did we have to plug in, guys? Anybody? Negative 12. X has to be negative 12. That's who you have to plug in to make a negative 28 come out. Again, Ms. Greenhouse can vouch this. We cannot get over the number of students who get to this problem and they just plug negative 28 in. If they wanted you to plug negative 28 in, they would have put them right there for X. All right, guys, do the last one. If f of x equals 16, find x. So again, notice, you have not been given an input. You have been given the output. You have to find out who has to get plugged in. So take your function and make it equal that output and solve for the input. Anybody want to help me out and tell you what you got? What'd you get for your input? 10. Yes, thank you. Good. You had to plug a 10 into this function to make a 16 come out. Everybody at home, do you see the difference between this questions and the ones before? Do you see how this one needs to find the input? You've been given the output. Okay, everybody here is okay with that? All right, perfect. Because like I said, most students, they get into a habit, they see this, they see that, like, all right, I'll plug 16 in. That is not a 16 to be plugged in. All right, so guys, you do have homework from yesterday on Delta Math that is due tonight if you haven't done it yet. There's a new assignment, homework number 2, for this stuff on evaluating functions that is due tomorrow night on Delta Math. I do apologize on yesterday's questions. I assigned 4 sections instead of 3, so it ended up being 17 total questions you needed to get correct. Today's homework, you have to get 13 correct. I am pretty sure that was actually right. So I do apologize about that mistake on my part. All right, if you're on the meet, if you have any questions for me, please feel free to hang out. Otherwise, you are free to go, and I will see you, some of you tomorrow. All right? Bye.
Miss Green,
Yeah.
I'm gonna talk to the